Last time we did 2 sum in O of n squared, checking every pair. Today, the answer interviewers actually want. 1 pass. O of n. The trick is a hash map, and one insight you can apply to half of all interview problems. 2 parts. Part 1 was the brute force. We are in part 2 now, the 1-pass hash map. Quick refresher on the problem. Given an array of integers and a target, return the 2 indices that sum to target. Same problem as part 1, different solution. In part 1, we used nested loops. For each I, we tried every j greater than I, n squared comparisons. At the maximum input size, that is 100 million operations. Today, we cut it to 10,000. Here is the insight. For each number we visit, ask, is there another number we have already seen that adds with this one to hit the target? If the current number is x, we need target minus x. We call that the complement. If we have seen the complement before, we have our answer. But how do we check, fast, have we seen the complement before? We use a hash map. It maps each value we have seen to its index. Lookup time? Constant. O of 1. That is the speed we trade space for. The algorithm in 4 moves. 1. Walk the array once, left to right. 2. For the current number, compute the complement, target minus current. 3. Ask the map, have I seen complement before? If yes, return the stored index and the current index. 4. If no, store current value mapping to its index, and keep walking. Trace on example 1. Array 2, 7, 11, 15. Target 9. At I equals 0, current is 2. Complement is 7. Map is empty, no match. Store 2 mapping to 0. At I equals 1, current is 7. Complement is 2. We check the map. 2 is there, at index 0. Return 0, 1. Done in 1 pass. The code in JavaScript. 8 lines. Create a new map. Walk the array with a for loop. Compute complement equals target minus nums I. If the map has complement, return first the stored index from the map, then the current I. Always in that order. Otherwise, set nums I mapping to I and continue. The numbers. Time complexity. O of n, 1 pass through the array. Space complexity. Also O of n, the map can hold up to all elements in the worst case. We traded space for time. In interviews, that is almost always the right trade. Why does this never use the same index twice? Look at the order. We look up the complement before we store the current number. So when we are at index I, only indices 0 through I minus 1 are inside the map. We can never match nums I against itself. Off by 1, solved by ordering. 3 traps. 1. Order matters. Look up complement first, store after. Reverse it and you may match a number against itself. 2. The map stores value mapping to index, not index mapping to value. Get the direction wrong and your lookup returns nothing useful. 3. Duplicates like 3 with target 6. First 3 goes in, mapping to 0. Second 3's complement is 3. Found at 0. Return 0, 1. Correct. The pattern. Hash map for the complement. Trade space for time. Look up what you need, not check what you have. This shows up everywhere. 4 sum 2. Split into 2 pairs, store pair sums. Subarray sum equals k, store prefix sums. Pairs with target sum divisible by 60, store remainders. Same trick. Now you can spot it. Next time you see a problem asking for a pair, a triple, or a sum hitting a target, think hash map of complements before you reach for nested loops. Subscribe at CodeBrainery. And tell me, which coding problem should I crack next? Drop the number in the comments.